Hello and welcome to the channel. Today's video is about the original SoundBlaster from Creative Technology, better known as Creative Labs in the US. This particular card is a SoundBlaster 2.0, a CT1350B, a pretty rare and expensive card by today's standards. This is a revision 6, which makes this the final revision of the final version of the original SoundBlaster, an 8-bit mono sound card that was marketed as an all-in-one sound solution. It was so inexpensive and popular in the day that it actually forced Adlib out of the marketplace and to file for bankruptcy. It was 100% Adlib compatible with the YM3812 chip from Yamaha, better known as the OPL2 for FM sound synthesis, and it had a set of chips for the Creative Music System, a prior and not very good attempt by Creative to get into the sound card business. And it had a computer on a chip, a microcontroller designed by Intel with an inbuilt ROM from Creative that actually allowed playback and recording of digitized sound. Here's a block diagram of the basic layout of the SoundBlaster 2.0 from the SoundBlaster manual. You can see the three different systems for creating sound on the board. The Creative Music System, which was 3 long thin chips, 2 from Philips and a custom programmable logic chip. But these just gave a bunch of buzzers basically. It wasn't very interesting, and by 2.0 Creative had realized this and just left the chips off. So they're very rare, and I'll explain how they came to be on my board a little later. There's the FM synthesizer, which made it 100% Adlib compatible. This is the musical instruments of the board. There was the big OPL2 chip for this, and also a small 8-pin digital to analog converter that was associated with it. Then there was the computer on a chip, the microcontroller from Intel, the digital sound processor, the big square chip in the upper left of the board, the CT1351. And I'll explain a little bit later how this allowed playback and recording of digital sound via the DMA system of the computer. The chip was controlled via command words that were sent to the CPU on the chip. All three of these systems were interfaced to the computer via an ISA slot, of course, and the bus interface chip, which is a very large chip on the board, the CT1336. There was a joystick port on the board and also a very primitive MIDI port. It wasn't until much later that Creative added proper MPU 401 support for interfacing with digital instruments and also other MIDI devices. And when they added it, it really didn't change their sales much at all. It's just not what people were buying SoundBlasters for. There's an analog to digital and digital to analog converter to change between the analog sound we can hear and the digital samples that could be stored on the hard drive, for example. There's a filter for the sound, and these are the two inputs, a mic and a line in, with an automatic gain control, so when it was too loud it would just automatically quieten it down. Now you might think that this is a user-controlled mixer like later SoundBlasters had, but there actually wasn't one on SoundBlaster 2.0. The sounds were just combined in a primitive way and sent to a power amplifier and the speaker. Before I move on, I should mention that I bought my card from another YouTuber, Necroware, who I'm sure many of you are familiar with. He has a great YouTube channel on retro PC hardware. I bought the card online and he just turned out to be the seller, so it was really great to get this from another YouTuber. And he'll actually turn out to be important to our story later on in the video when we discuss the Creative Music System. Given that this is a relatively rare and expensive card, which most people wouldn't have, I thought it would be interesting to listen to how it sounds. So I've installed Windows 3.11 on my Eurobit 386 machine, along with all of the software that came with the SoundBlaster 2.0. It was distributed with a whole pile of disks, and I bet you're thinking, wait a minute, isn't a 386 a little bit late for an 8-bit sound card? And I must admit I thought the same thing myself, but this card was actually released toward the end of 1991, and my card was actually manufactured in 1994. So here's an advertisement for a SoundBlaster Pro that was actually released around the same time as this card. This was a 16-bit stereo card, and you can see that they're still advertising the SoundBlaster alongside it. So I guess they were just people that wanted it as a cheap option or still had the old hardware that they hadn't upgraded yet. Anyway, let's check out these programs, and as far as I can see, it's only going to allow us to check out the sound playback and recording and the OPL2 MIDI. There's nothing here for the Creative Music System, and that makes sense since the chips weren't actually distributed with the SoundBlaster 2.0. The first program here just loads the next two. It's a kind of remote control for the Wave Player and the Midi Player. So let's open both of them so we can see what they look like. And they actually distributed some samples with these. So if we go into the samples directory, there's just one wave sample, which I'll play for you. I kind of expected there'd be something a little bit more substantial than that, but that's what's there. And in the MIDI player, there's a fair few samples, and I'll show you just a few seconds of each of these. So those are the samples that came with it. So I guess if we want to have any more fun than this, we probably have to load some games. Before I do that, let me just show you the other programs that are here. Soundo LE is pretty primitive. It's just a sound recording and playback program, and its functionality is basically duplicated in Wave Studio, so I'm not going to spend any time on that. The SoundBlaster configuration doesn't actually change the settings on the card. It wasn't until much later that Creative had the ability to do this. You actually set the base address and IRQ with jumpers on the card, and all you're doing here is just making those agree with the Windows settings. There's a little game called Mosaic here, and it's only included because it has some sound effects. Wave Studio is a little bit more substantial. It's a sound recording and playback program, but it has some special effects. So I recorded some samples in advance so we can listen to the quality of the sound, and I'll leave it for you to judge whether this is hi-fi or not. The first sample is my voice, and you can hear that it's really quite whiny and there's a lot of noise. I'll let you guess for yourself what the other samples are. And here's the third sample. Now, as I said, there's some special effects. In the special menu, you can reverse the waveform, add an echo, invert the waveform, fade in and out. You can even play back at a different frequency. So let me show you an echo. I'll just add that to this sample here, and we'll listen to what that sounds like. The first sample is my voice, and you can hear that it's really quite whiny and there's a lot of noise. And of course, we have to play it back at twice the speed. You can see that the playback rates are 11, 22 and 44 kilohertz. It can't actually record at those frequencies, but anyway, let's play this sample back at twice the speed just for fun.
The first sample is my voice, and you can hear that it's really quite whiny and there's a lot of noise.
Alright, I think we've run out of stuff we can do here. We need to set up some games, in particular one that can actually use the Creative Music System. Now I mentioned that the sockets for the Creative Music System chips were actually just empty on the SoundBlaster 2. Creative just left them out. The Philips ones aren't that hard to get, but the custom Logic chip was as rare as hen's teeth because no one was interested in this feature, so there were very few of these out there. But eventually a user on the VCF forum, Chuck G, managed to find an actual chip in the wild and reverse engineered the logic equations and program one of his own. Now, eventually it was recognized that this didn't actually work with some of the later SoundBlaster 2 boards. There are revisions 2, 3, and some of the revision 4 boards, which usually have a revision number up the top here. And then there's some revision 4 boards, revision 5 and revision 6, like what I have here, where the revision number's down here. It's the first 2 digits of this number. The remaining 4 digits are a date code for the PCB design. Anyway, a user on the Vogons forum, Suntac, managed to come up with a solution that worked with the later boards, but he hadn't made his work public, and Necroware actually came along and came up with an alternative solution which he put under the GPL3 software license. And this actually prompted Suntac to release his work under public domain, so now pretty much anyone can do anything they want with this. And this is actually how I came to get this board. Necroware had to get some actual boards to try this out on for testing, and he just sold these off, and I managed to get one of those. Now, the game that I've chosen to demonstrate the creative music system is Loom, and if you put a G after the Loom demo executable, it will actually use the Game Blaster, which is the same as the creative music system. Now listen carefully, and I think you can hear that it really buzzes quite a lot. It sounds okay. There are actually 6 oscillators in each of those Philips chips, which gives a total of 12 voices, but it's still a bit rough. Basically, they're just square waves. Now we'll listen to the same thing again, but we're going to use the OPL2, basically Adlib sound, and I'm sure you'll recognize an immediate difference in sound quality. The tones are just so much smoother and rounder. But there is one problem with this card, and it happens with both the creative music system and also the Adlib sound. When I restart the machine, this is what happens. Even a hard reset doesn't always fix that problem. At least with the creative music system, it doesn't seem to ever fix the problem. You really actually have to turn the machine physically off and on to make it stop at the note. It's a little bit of an inconvenience. When I bought this card, I really wanted to know how to program it, so I bought the SoundBlaster book, which, despite the fairly boastful name, is actually quite well regarded, I believe. I believe it was originally written in 1992 in Dutch by some Demosceners and then translated to English in 1994. Ultraforce. Yeah, that sounds familiar. By the time this book was written, they already had a section on the Soundblaster Pro, and then they even added an appendix on the Soundblaster 16. When I first got the book, I was a bit worried that I had the wrong thing because these I/O addresses don't match my card. I can only set the base address to 220 and 240, but apparently that's standard for the Soundblaster 2.0. This is actually the Soundblaster 1.0, and of course my card didn't match what was on the other side of the page, which is the Soundblaster Pro either. I'm sure this is a great book, but the creative documentation is actually pretty good as well, at least if you already understand how to program the DMA in the computer itself. The way that the digital sound processor of the Soundblaster plays a sample back is it makes an interrupt request to the PC to ask for data from main memory. And this data is then transferred back to the Soundblaster using the Direct Memory Access Controller, which is a device on the PC for very rapid transfer of data between memory devices without the CPU being involved. The CPU would have to handle the interrupt request, but the actual data would be sent via the DMA controller. Now, this mechanism actually ended up causing some trouble in the end, because once the data in the DMA buffer in main memory runs out, the DSP has to send another interrupt request for more data. And at very high transfer rates, there isn't enough time to set up for the new transfer. And Microsoft wanted a really high transfer rate for their multimedia PC specification, so Creative had to come up with something better. And this was one of the innovations in the SoundBlaster 2. They support something called auto init mode for DMA transfers. This is where it uses the same DMA buffer over and over again and just automatically goes back to the start and starts reading the same buffer again after it reaches the end. Now, this might sound like a mistake because it's going to mean that the same sample is going to be played over and over again and it's just going to repeat. But the idea is that you break the buffer into two halves, and while the first half is being read by the sound card, you put new data in the second half. And then when it's halfway through, you swap, and the second half is being read by the sound card while you're putting new data in the first half. So this allowed for a much higher transfer rate, up to 44 kilohertz on the SoundBlaster 2.0. And by the way, you now know what those funny blaster settings are that you need to set in auto-exec-bat whenever you have a Sound Blaster. The original Sound Blaster just had the first three of these. There was the base port address. There's actually a bunch of ports all starting at that address, which the CPU writes to control the Sound Blaster. And there are registers for reading and writing, for control words, for the DSP, and so on. The I is for the interrupt request line of the CPU that the DSP sends an interrupt along to request data. And the D is the DMA channel of the DMA controller in the PC, which is going to be used to do the data transfer to the sound card. Now, along with the SoundBlaster 2.0, Creative released a couple of games, presumably to show off how good it was, and the first of these is Lemmings. Now, Lemmings for the PC came out in 1991, and the disc that came with the SoundBlaster 2.0 is just repeatedly asking for the Lemmings disc to be inserted. So I don't have time to figure out what was going on there, and so I'm running a version here with a Cracktro. And this is a beautiful example, also from 1991, by the Humble Guys. There's a few funny jokes along the way. They ask, where's the blitter chip, which is something you'd expect on, say, an Amiga 500, which perhaps shows the history of these guys before they switched to cracking on the PC. The other game that Creative distributed with the SoundBlaster 2.0 is Indianapolis 500. This was released a little bit earlier in 1989. And despite the game being very graphically impressive for the era, this particular version doesn't seem to produce sound with my SoundBlaster 2.0, which you just heard working perfectly well with Lemmings. I have it set up correctly with the correct blaster settings, and there's no configuration or setup option in the files for this game. There is a sound option in game, but it doesn't do anything, and there's nothing at all in the manual. So I'm going to move on to something that certainly will work with this Sound Blaster, and that is a demo scene demo from the era. This is Vector Demo by Ultraforce, and these are the people that actually wrote the Sound Blaster book that I showed earlier, so I thought it would be great to show off a little bit of their work for a few seconds. So there's some really cool 3D stuff there as well, which I particularly like. Anyway, that's an example of what you can do with the Sound Blaster if you're a real expert in how to use it. Well, that's where I'm going to leave it for today. There's much more that could be said. I could cover the history of the original Sound Blaster, the three versions, 1.0, 1.5 and 2.0. The first version came out in stores for Christmas in 1989, and already within a year they had the most popular sound card on the market. In fact, by 1992 they had pushed Adlib into bankruptcy. Adlib went on a kind of advertising spree just before that in panic because Creative had gotten so much of the market share. And by 1995, Creative had 70% of all sound card sales. Or we could look at the digital sound processor chip in more detail and the internal workings and the ROM dumps that people have done of that. But there's infinitely many topics to cover, and this video is already long enough, so I'm going to stop here. Thanks very much for watching, and I hope you enjoyed this look at the original Sound Blaster and my 2.0 version, the rare CT1350B. And I hope to see you in a later video. Don't forget to like and subscribe. See you later. Bye.